this video, I'm going to be covering grade 9 and grade 10 equations. I'm just going to give you a quick overview based on some past paper questions to deal with the equations that you're faced with in grade 9 and grade 10. The types of equations that you can expect to find are linear equations, quadratic equations, exponential equations, inequality type questions, and simultaneous equations. And I'm going to be doing all 5 of these in this video. The question says, solve for x if 2x squared minus 5x plus 2 equals 0. So this is just a trinomial question. So as I can see, I have a coefficient of my x squared, or I have an a value. The method I like to use when there's a coefficient to the x squared is called the slip and slide method. I saw it on Pinterest a little while ago and I thought it was literally so fascinating. So I did a whole video on it. And it just really helps to factorize trinomials when you have a coefficient to the x squared. So what we're going to do is we're going to take this coefficient and we are going to multiply it with the c value. So we take the a value and we multiply it with the c value. So now I have x squared minus 5x, and then I have 2 times 2, which is positive 4, equal to 0. All right, now I'm going to factorize this like a normal trinomial. How do I factorize this like a normal trinomial? I look at my third term. My third term is positive, so that tells me the signs are going to be the same. What are they going to be? I look at my middle term. My middle term is a negative, so they're both going to be negative. It also tells me that I'm adding the factors of 4 to give me my middle term, which is a 5. What are the factors of 4? 1 and 4, 2 and 2. Which of those, when added together, give me 5? The 1 and the 4. So now I'm going to have 2 brackets equal to 0, and they're both going to have the same sign. They're both going to be negative. X squared factorized becomes x and x, and I take the factors that I just chose over here of 1 and 4. All right, now I'm going to take this 2, my a value, and I'm going to put it into the denominator over here. So I'm going to create fractions. So I'll put it over 2 over 2. Now I'm going to quickly simplify these 2 brackets. So I have x minus 1 divided by 2 is a half into x minus, and 4 divided by 2 is 2, but I'm going to keep it as a fraction. So I'm just going to say 2 over 1. And then I just do my final step. And that final step is taking this denominator and putting it to the front of each of the brackets. So now I'll have 2x minus 1, x minus 2 equals 0. So now I've factorized it both. To solve a quadratic equation, we take everything to one side, we make it equal to 0, we factorize fully, and then we make each factor equal to 0. So everything was on the one side, everything was equal to 0. Now we've factorized fully, so we can do our last step, which is make each factor equal to 0. So therefore, 2x minus 1 equals 0. So that's my one factor. Or x minus 2 equals 0. And that was my other factor. So if 2x minus 1 equals 0, that means that 2x is equal to, I take the minus 1 across, it becomes a positive 1. Then I'm going to divide both sides by 2. So therefore, x is equal to half. Or if x minus 2 equals 0, I take the minus 2 across, so x is equal to positive 2. The next question says solve for x, given that x squared minus 6x plus 8 equals 0. For this one, we just have a normal trinomial, so we're just going to factorize it. So we look at our third term. Our third term is positive 8. So that tells me 2 things. It tells me that the signs are going to be the same. What are the signs going to be? They are both going to be the middle term sign, which is negative. So both the signs are going to be negative. And I'm adding the factors of 8 to give me my 6. What are the factors of 8? 1 and 8. And 2 and 4. Which of those factors, when added together, give me 6? That's 2 and 4. So I'm going to have 2 brackets equal to 0. The signs are going to be the same. Both the signs are going to be negative. X squared factorized becomes x and x. Then I take the factors I've just picked of 2 and 4. But I'm solving for x. So therefore, x is equal to 2 or x is equal to 4. My next question is 1 over 2 to the power of 3x plus 1 is equal to 32. I have a half to the power of 3x plus 1 equal to 32. Now this is an exponential equation. How do I know that it's an exponential equation? Well, because the exponent is the variable. To solve an exponential equation, I follow these steps. Number 1, I make the bases the same. Number 2, I drop the bases. Number 3, I equate the exponents. Now, in order to make these bases the same, I'm going to notice that I have a fraction on the one side and I have a whole number on the other side. So I want to make the fraction a whole number. Now remember, I can make any fraction a whole number if I remember that if I take that 2 from the denominator and I move it to the numerator, I just need to change the sign of that exponent. So now I'm going to have 2 to the power of negative 1 raised to the power of 3x plus 1 equal to, and 32 as a base of 2 is 2 to the power of 5. If you want to use a calculator to show your bases, what you do is you type in your 32, you push equals, and then you push shift and your factor button. There's a gold factor button on your calculator. Now I have my exponential law of raising a power to a power. So this negative 1 is being raised to the 3x plus 1. Which means that when I have a power raised to a power, I'm going to multiply those powers together. So I have 2 to the power of negative 1 times 3x is negative 3x. Negative 1 times positive 1 is negative 1. And that is equal to 2 to the power of 5. So now I have the same bases, which means that now I can drop the bases and equate the exponents. So I have negative 3x minus 1 equal to 5. So now I'm going to solve this like a normal linear equation. So I have negative 3x is equal to, the 5 stays the same, stays first. This negative 1, when it goes across, now becomes a positive 1. So I have negative 3x equal to 5 plus 1, which is 6. Now I want to isolate my variable. I want to isolate my x, which means that I'm going to divide both sides by the coefficient of the x, which in this case is a negative 3. So therefore, negative 3x divided by negative 3 is x, is equal to 6 divided by negative 3 is negative 2. Now I have an inequality question that says, given 4 minus 2x is less than 16, where x is an element of the real number, it says solve the inequality and then represent your inequality on a number line. In grade 9 and grade 10, you have linear inequalities. When you move on to grade 11 and 12, then you get your quadratic or cubic inequalities. Now with a linear inequality, you're going to solve it similarly to how you would solve a linear equation. So that means that you isolate your variable, all right? So you want to get your variable to one side of the inequality, you want to get your numbers to the other side of the inequality. Remember, when working with an inequality, you have your crocodile teeth, all right? Now, your crocodile teeth change direction only when you divide or multiply by a negative. So if they're facing this way and you divide by a negative, then they're going to face that way. I could have used the other hand, but did I? No. So remember, when you divide or multiply by a negative, your inequality sign flips around. So we are going to isolate our variable first. So if we have 4 minus 2x is less than 16, I want to start by isolating this x. So minus 2x, keep everything the same, is less than 16. The positive 4 when it goes across now becomes negative 4. So now I have minus 2x is less than 16 minus 4, which is 12. All right, so now I have minus 2x is less than 12. I don't want a minus 2x, I want an x by itself. So to get the x by itself, what I'm going to do is I'm going to divide both sides by negative 2. But now I'm dividing by negative, which means my crocodile teeth are going to flip around. So negative 2x divided by negative 2 is x, and 12 divided by negative 2 is negative 6. But my inequality sign was facing the right-hand side. When I divided by that negative, now it's going to flip around and it's going to face the left-hand side. So x is now greater than negative 6. So now I've solved the inequality, and the next question says represent your answer on a number line. In the original question, it said x is an element of the real number system. Now this x being an element of the real number system is what we call a restriction. By it saying that x is an element of the real number system, it's not really giving us much of a restriction. So it's telling me it can be any number that falls in the real number system. So natural numbers, whole numbers, integers, rational numbers, irrational numbers, any number. A restriction that you need to keep your eyes open for is if it said to you, for example, x is an element of the integer system. Because if it said x is an element of the integer system, the natural number system, or the whole number system, then that would exclude all your decimals and all your fractions. So just remember to keep that in mind, because that will affect how you were to draw your number line. But now we have a number line. There's not really a restriction. We're basically only going to have one number on our number line. So we just have the number -6, and we're going to have a dot. Now, is that dot colored in or is that dot not colored in? That is dependent on the crocodile teeth, whether it has a tongue or not. You can see there's no tongue, which means it's a not colored in dot. It's an open dot. X must be greater than -6. Which direction will x be greater? It'll be greater going in that direction. And there I've represented it on a number line. All right, this question, we have a double inequality. It says solve for m, and then it also says hence write down the number of integers that satisfy this inequality. All right, so we're still working with a linear inequality. The degree of this inequality is still 1. So to start isolating this, m means that I want to get rid of this -8. Now I'm going to get rid of it by taking it to another side of the inequality, but I can't just take it to the one side of the inequality. I have to take it to the other side as well. I need to take it to both sides so that I can keep this balanced. Now, what was there first, stays the same. That's the best way that I would explain how to solve a linear equation, is what was there first, stays the same. That way you're not going to mess up your signs. So the -11 was there first, so the -11 stays first. Now, when that -8 goes across, it now becomes a +8. It's no longer in the middle, so I'm going to have just the 3m. I'm going to keep my crocodile teeth exactly as they are. Then I'm going to keep my crocodile teeth. My 4 was there first, stays the same. The -8, when it goes across, becomes a +8. So -11 plus 8 is -3, is less than or equal to 3m, which is less than 4 plus 8, which is 12. Now what I need to do is I still want to isolate that m. So in order to isolate that m, I'm going to divide that m by 3. But what I do to the 1, I'm going to do to all of them to keep everything balanced. So -3 divided by 3 is -1. It's less than or equal to 3m divided by 3, which is m, which is less than 12 divided by 3, which is 4. Now you can see I didn't switch my crocodile teeth around because I didn't divide or multiply by negative. All right, now it says, hence write down the number of integers that satisfy the inequality. So my inequality, m, is between -1 and 4. Now it says the number of integers. So integers are -1, 0, 1, 2, 3, etc. Now I'm not going to list the integers that satisfy this inequality because it didn't say list them. It said what is the number of them. All right, so we know that m can be equal to -1. So -1 is my first integer that satisfies this. What's the next integer after -1 but before 4? 0. Then 1, then 2, then 3. But it can't be 4 because 4 is not included, which means that there are 5 integers that satisfy this inequality. All right, now we have this question that says solve simultaneously for x and y. 5x plus 4y equals 21. 2x is equal to 3 minus y. So our first step is we are going to just label our equations. So we have equation number 1. And we have equation number 2. When working with simultaneous equations, we have to start by isolating a variable. Now, to isolate a variable means 2 things: that the variable needs to be alone and that the variable needs to be positive. If I look at the equations, I have 5x plus 4y and then I have 2x. So the 5x and the 4y, it's not the same coefficient, so I'm not going to work with that. Then I have 2x is equal to 3 minus y. Now you'd want to say, okay, let's just leave it as it is, but there's a coefficient in front of the x. So I have 2 options with this one. I can either divide everything by a 2, or I could isolate the negative y on the other side. So that's what I'm going to do. I'm going to take that negative y across. It's going to become positive y is equal to, the 3 is going to stay on the right hand side, and the 2x when it goes across is now going to be negative 2x. So I'm going to label this equation number 2a. Now you could label your equation number 3, but I like to label it with an A so that you remember which equation you used to form that equation. So this is equation 2a, which means I used 2 to create it. Alright, so now what I'm going to do is I'm going to substitute equation 2a into equation 1. So in equation 1, where I see the y, I am now going to replace it with the 3 minus 2x. I'm going to have 5x plus 4. Now in place of the y, I'm going to put in brackets 3 minus 2x is equal to 21. 5x plus, this 4 is going to jump inside this bracket. So 4 times 3 is positive 12. Positive 4 times negative 2x is negative 8x. And that is equal to 21. Now I'm going to collect my like terms. So I have 5x minus 8x. So 5x minus 8x is negative 3x. Equal to, the 21 stays the same, stays positive. The positive 12, when it goes across, now becomes negative 12. So now I have minus 3x equal to 21 minus 12, which is 9. Now I want to isolate that x further. I'm going to divide both sides by negative 3. So negative 3x divided by negative 3 is x, and positive 9 divided by negative 3 is negative 3. Now I have my x value being negative 3, but I still need to find my y value. So I'm going to take that x value and I'm going to substitute it into an equation. Which equation am I going to substitute it into? I'm going to substitute it into the equation that I already manipulated, because then y is already the subject of the formula. Now you could go into any of your equations that they're all the same. So I just like to go into the easier of the equations. So now what I'm going to do is I'm going to substitute x equals negative 3 into equation. And now which one did we manipulate? We manipulated 2. So I'm going to go into equation 2a. So I can say, therefore, that y is equal to, if I look at equation 2a, it's 3 minus 2x. I'm going to have 3 minus 2 in place of the x. I'm going to put what I just said, x is equal to. So therefore, y is equal to 9. So you can see that I've solved for the x, and the x is negative 3, and I've solved for the y is positive 9. If I look at one more simultaneous equation, I have minus 2x minus y is equal to 10, and 3x minus 4y is equal to negative 4. So I start by writing out my equations, and I'm just going to label them. So I have equation number 1, and I have equation number 2. So now I'm going to isolate a variable. So if I look over here at equation number 1, I've got a negative y, the coefficient is 1. Now when the coefficient is 1, it's pretty easy to just manipulate that one. But remember, to isolate your variable, it has to be alone and positive. So now what I'm going to have is I'm going to have negative y equal to, the 10 stays the same, stays first. The negative 2x when it goes across becomes positive 2x. But I don't want a negative y, which means that I need to divide everything by negative 1. So negative y divided by negative 1 is y, equal to negative 10 minus 2x. And which equation did I use to make this equation? I used equation 1, which means that this is now equation 1a. So now I can substitute equation 1a into the other equation. So in this case, it's equation number 2. So that means I'm going to look at equation number 2, and where I see a y, I'm going to replace it with what I've said that y is equal to from this equation, which is minus 10 minus 2x. So I have 3x minus 4. Remember, when you substitute with brackets in place of the y. I'm going to put what y is, which is minus 10 minus 2x, carry down the whole equation, is equal to negative 4. Now I'm going to simplify this, so this minus 4 is going to jump inside this bracket. So now I'm going to have 3x, negative 4 times negative 10 is positive 40. Negative 4 times negative 2x is positive 8x, equal to negative 4. Now I'm going to collect my like terms. So I have 3x plus 8x, and 3x and 8x is 11x, equal to, the minus 4 stays the same, stays first. The positive 40, when it goes across, now becomes negative 40. So I have 11x equal to minus 4 minus 40 is negative 44. But I want to get the x by itself, so I'm going to divide both sides by 11. When I divide both sides by 11, therefore x is equal to negative 44 divided by 11, which is negative 4. So now I have x equals negative 4, and I'm going to substitute that into the equation that I just manipulated. So that means that I'm going to have y equals minus 10 minus 2x. So therefore, y is equal to minus 10 minus 2. In place of the x, I put what I said x is equal to, which is negative 4. So therefore, y is equal to negative 2. So now what I've done is I've said that x is equal to negative 4 and the corresponding y value is negative 2. I hope that you've enjoyed this video and that you've taken down notes while you've watched it. Remember, you can't get good at maths by watching someone else do it. The more you do, the better you'll be.